Hello everyone! Ang ating aaralin sa session na to is all about Zero-Slump Concrete and Roller Compacted Concrete. For the start, let us have first a review about concrete. And this is actually its general definition. Concrete is the most commonly used man-made material on Earth. It is a construction material composed of cement, fine aggregates, coarse aggregates, water, and sometimes an admixture with water, which then hardens in time. So let us have a review on the types of concrete. First, let us have the wet cast concrete. Actually, it is flowable form of concrete, this wet cast concrete. Then, often used in larger pieces that are more complex and need flowability in the concrete in order to consolidate around reinforcement and throughout the form. For the dry cast concrete, we actually have the zero-slump concrete. And it is actually used to increase production rates and lower the manufacturing costs. Another characteristics, we have the low water to cement ratio, then resembles hard clay and dries within an hour, and allows to use one form and pour numerous pieces without deformation. And that's all about the dry cast concrete. Now we have the significant differences in manufacturing. Wet cast or self-consolidated concrete and dry cast or zero-slump. First, we have the casting and consolidation processes, forming equipment, curing, and handling equipment to consider. And here is our focus. It's all about the zero-slump concrete and roller compacted concrete that we have to learn. If we will talk about the slump is actually the measurement of workability and consistency of concrete. Concrete workability is determined by the slump test in accordance with ASTM C143. As we can see in the figure, we have here the standard size of our slump cone apparatus, which is actually having the top diameter of 10 centimeter and at its bottom, for its base, we have 20 centimeter as its diameter and having a depth in size of 30 centimeters. Ano pang gagawin natin dito? Ilalagay natin ang concrete sample inside the slump cone apparatus, and then after processing, i-release natin ang ating slump cone apparatus. Aalisin natin ang slump cone, sample natin, and then right after, all we have to do is just to measure the depth of the slump. Ito kasi yung makakatulong natin para ma-determine natin kung ano bang klaseng konkreto ang ginagawa natin. Actually, may kinalaman ang slump sa mga construction projects na ginagawa natin upang makita natin ang future ng ating produkto, kung ito ba ay magiging matibay, kung ang sample ba natin ay maayos. So mayroong iba't ibang klase ng slump. Una ay yung tinatawag nating true slump. The second one, we have the zero-slump, which is actually a potentially non-plastic. And then we also have the collapse slump, potentially non-cohesive. And the last one, we have the shear slump, no displaced center. As we can see here, the Kai na nag-measure ng depth ng slump so that ma-determine niya kung pasok ba ito sa standard. Again, these are the different types of slump, starting with the true slump, zero, collapse, and shear. So dapat alam natin yung mga description ng mga slumps natin. Kapag shear, kita niyo naman, medyo slant siya dito, ng pa-curve ng konti. Feel yung nasa taas, pero yung up portion ng nasa taas is empty. And then ito, flatten yung ating slump. Ibig sabihin, sobrang tubig ng ating mix. Dito sa zero, low water cementation sigurado yan. And then this is the true slump. So these are the activities that we can see na ginagawa ng isang guy na nag-experiment. Ito, nag-measure siya. I think this is the true slump sa figure 1. Nag-measure siya ng depth. And then zero slump, ibig sabihin wala ka nang susukatin na depth. Siguro, konti lang yung water na nailagay dito. And then ito, kaya may slump tayo. Siguro tama lang yung slump natin dito at tama lang yung tubig na inilagay sa ating concrete sample. And then here, katulad ng nakita natin kanina sa 4 na klase ng slump na aking pinakita, medyo nakaslant siya. No? Nakaslant siya dito. Dito sa pangalawa naman is hindi gaano yung angle na makikita natin doon sa curve. While here, flatten. Pagka-release ng slump cone apparatus, mabilis na nag-flow yung concrete natin kaya ganyan na lang yung itsura niya. And then sobrang taas ng slump measurement natin dito, mataas ang depth. So the slump, ito yung konsepto Bakit kailangan nating i-test ang slump? Ito kasi yung nakikita natin in the future kung paano ba mag-work yung concrete na ating ginagawa as a sample. The higher the slump, the more workable the concrete. On the other hand, a low slump will result in poor workability. Kapag tumataas ang slump, ibig sabihin, maganda ang workability ng concrete. Pero kapag masyadong mababa yan, ibig sabihin, mahina yung slump natin, mahina yung magiging produkto natin sa konkreto. For the classification of mixture na nakikita nyo sa first column, and then sa slump test, ito yung result, ito yung depth ng slump natin. And then, saan ba pwedeng gamitin yung mga result ng slump natin? Yung konkreto, yung sample natin. Saan bang application pwede yan? For the classification of mixtures, very dry mixes or poor workability kapag ang slump test is ranging from 0 to 25 millimeters, application is for road making. And then low workability mixes, 26 to 50 millimeters ang depth ng slump natin. Foundations with light reinforcement yan. Medium workability mixes ranging from 51 to 100 millimeters. Ito naman yung tinatawag nating normal concrete or normal reinforced concrete placed with vibration. Diyan pwede yan, yung application niya. For the high workability mixes, 100 to 175 millimeters, its application is for reinforcing tight spacing or the concrete has to flow a great distance. So we have now the zero-slump concrete dahil naipakita naman kanina yan. So ano pang meron sa zero-slump concrete? Di ba't 4 yan? We have the true slump, the zero, and of course we have another 2 kinds of slump. Pero dito muna yung concentration natin regarding about the zero-slump concrete. Zero-slump concrete, and this is actually its appearance. Concrete of steep or extremely dry consistency showing no measurable slump after removal of the slump cone. Ibig sabihin, walang depth, sobrang taas ng ating slump. And this is actually an image of a zero slump. Hindi nagbaba yung concrete natin. Na-maintain yung shape niya, na-maintain yung figure niya. Unlike doon sa nag-flatten yung slump dahil mabilis ang flow, dahil siguro sobrang dami ng tubig, nag-flatten yung concrete sample natin. Okay, so this is another figure. For the major application of zero-slump concrete, pwedeng gamitin ang major application of zero-slump concrete sa roller compacted concrete or RCC, na kung saan ito ay ginagamit natin sa pag-construct ng mga dam and of course pavement construction also. So dyan applicable ang zero-slump concrete sa roller compacted concrete na tinatawag natin. Of course, pwede din gamitin ang zero-slump concrete sa mga precast concrete. Just like for example, the concrete pipes and hollow core slab. Again, under ng zero-slump concrete, considerable cost reductions in the construction of cement pavements can be realized by use of dry or zero-slump concrete mixtures, plates, and spread by base course or asphalt spreaders, and compacted with heavy vibratory rollers. The best method for selecting the water content of RCC mixtures for small projects is by the moisture density relationship that is used for determining optimum moisture content and maximum density of salt mixtures. Laboratory testing should be used to establish these values based on the content of cementitious material and grading of the aggregate. As water to cement ratio increases, strength decreases. Kapag dumadami yung tubig sa semento, sa konkreto, siyempre umiina yung concrete sample natin. Hindi natin masyadong nare-reach yung strength na gustong ma-reach ng ating concrete sample. It is because of the reason of water to cement ratio is very high. Pero kung lower yan, ma-reach natin yung strength na gusto natin ma-reach or ma-maintain sa ating concrete. The water content of pervious concrete is critical and is usually confined to a narrow range. If the water content is too low, a poor paste to aggregate bond and loss of strength occurs, and it is difficult to get the materials properly mixed. If the water content is too high, the paste will not adhere to the aggregate and will flow downward, blinding the void structure and also causing a loss in strength. So, causing a loss in strength. For the manufacturing, dito muna pala tayo. The production of a well-mixed zero-slump concrete requires special attention. Black and precast producers are aware of the difficulty in producing a continuous supply of a consistent and uniform mixture, and usually employ specialized mixing equipment to meet their specific needs. For the manufacturing of zero-slump concrete, due to its poor workability, zero-slump concrete needs additional effort in its consolidation process and made use of the following specialized equipment. First, we have the vibration tables, compaction or drop tables, pipe machines, or extrusion presses. We have this specialized equipment and we call them as the vibration table. Specialized equipment again, we have the pipe machine or extrusion presses as mentioned a while ago. For the forms and accessories in manufacturing of zero-slump concrete, forms should be more rigid to efficiently transfer the vibration energy. Added strength and long-term durability in formwork are also needed to withstand the continuous impacts of consolidation. For concrete curing, control. To enhance concrete's desirable properties such as strength, impermeability, surface hardness, and crack resistance, the curing process is controlled. If not properly cured, dry cast products have tendency to dry too quickly and crack due to surface moisture loss. Curing in a controlled, moist environment dramatically increases the concrete's rates of strength development. Advantages: first, fast construction. Second, high production capacity. These are the precasts. Use less cement paste, high strength, low drying shrinkage, and low permeability. For large suppliers, companies with high demand from the market, the use of zero-slump concrete could increase the rate of production and lower the labor costs due to its automation and fast production, without sacrificing the quality and strength of a concrete product, while also increasing the profit to be gained. And then we also have disadvantages. It needs many trial mixing for the required consistency, and then subjective to variation of material properties. Now let's have the roller compacted concrete. It is a concrete of zero-slump consistency, and it is hardened state. RCC issues when strength, durability, and economy are primary needs. Application in construction, dito nagagamit ang RCC or roller compacted concrete. It is usually used in rehabilitation or construction of the following. Pwede siya sa dams, sa mga roadways, airfields. Pwede rin gamitin ang produktong yan sa parking lots, power plants, road shoulders, storage facilities, military facilities, and let us also include industrial complexes. Note, depending on the desired thickness and width of the installation, the concrete can be laid very quickly from 60 to 120 meters per hour. For the materials, production, and placement. So the materials that we're going to use are the cement, water, aggregates, or we have the gravel or crushed stones. Take note, do not choose the round stone kasi masyadong smooth yun. Dapat ang gravel natin is angular o kaya yung tinatawag natin mga crushed stones. Although it exhibits the same materials, with traditional concrete, the mixture is drier and adequately stiff to be compacted by a vibratory roller. For the transportation, roller compacted concrete is transported, placed, compacted using earth and rockfill construction equipment. So what do we have with the RCC? What are its characteristics? Number one, tough. Second, durable, strong, sustainable, versatile, and resist freezing and towing. So what are the advantages of roller compacted concrete? Resistance to shoving and pushing, minimal maintenance, no rotting, no potholes, resistance to oil spills. Formworks costs are minimized or eliminated. Rebar is not required. High volume placement. It does not deform under heavy concentrated loads. Span, soft localized subgrades. Can withstand high temperatures. Reduce cement consumption as the linear concrete mix can be used. No concerns about high heat release from drying concrete. The cost of transporting, placement, compaction of concrete are minimized because concrete can be hauled by dump trucks, spread by bulldozers, and compacted by vibratory rollers. What are then its disadvantages? Number one, although it is used to efficiently design RCC dams to be the least cost alternative when compared to other types of dams, there are also conditions that may make RCC more costly. Situations where RCC may not be appropriate is when aggregate material is not reasonably available. The foundation rock is poor quality or not close to the surface, or when foundation conditions can lead to excessive differential settlement. Disadvantage of RCC. Another one, dams repaired or constructed with roller compacted concrete may suffer from water seepage. That is why water stoppage layers shall be considered. Roller compacted concrete time construction. If you want to learn more about this, all you have to do is to watch this video sa YouTube. Sa YouTube mapapanood yan. Kundan Trakan Sondam. It is actually an example of a dam na ginawa o nilikha gamit ang roller compacted concrete so that you may learn more. This actually its image. Ito naman yung tinatawag nating Town South Dam na makikita sa Missouri. And you can actually watch this sa YouTube. And ito yung link na aking ibinigay para mapanood din ninyo ang isang halimbawa ng dam na ginamitan ng roller compacted concrete. And take note, kailangan zero-slump concrete. And if you want to learn more about everything that I have discussed to you in our session, these are our references that you may use so that you may learn more. Thank you very much, and God bless us all.